Here's a sketch of 1 byte. I've got my 1's place, 2's place, 4's, 8's, 16, 32, and so on. So this just represents 1 byte. What if I put 1's as each one of those bits? If I did that, and then I said 1 times 128 plus 1 times 64 plus 1 times 32, and added all those up, I'd get 255. Now that's for an unsigned byte. So what kind of a range does that have? Well, it can go anywhere. If these were all zeros, it could go anywhere from 0 to 255. But what happens if I give up that top bit, that most significant bit, to have a sign? And then I put 1's in all the remaining bit spots. Let's take a look. Now when I say 1 times 64 plus 1 times 32 plus 1 times 16, I get 127. What did we, now, did we gain anything? Well, yeah, I can have a sign out here. What's my smallest value going to be? If you check in the book, it says the smallest number is negative 2 to the 7th. Well, how big is that? Well, 2 to the 7th power is 128, so I've got negative 128. Which means a signed byte can range from negative 128 all the way up to 127. Think about that just a minute. How big is that range? How wide is it? If you subtract negative 128 from 127, guess what you get? The answer is you get 255. What does that mean? Let's draw a number line. So here's 0, and here's 255. In other words, our unsigned byte can go from 0 to 255. So if I just made a line representing that. Now suppose I took that line and I shifted it down. Same length line, and I shifted it down. And this number down here is negative 128. And up here, it's 127. I would have the same overall distance, but now it'd be like this. So I've just shifted this range, if you will. I've still got the same number of numbers, but now then I can have a sign, but everything costs something. What am I giving up? That signed byte can't hold as large of a positive number as it used to be able to. Let's take a look at a signed byte, and this byte has the value positive 6 in it. I know it's positive because the signed bit is 0, and then I've got a 4 and a 2 bit here. So there's my 6, that's a 0, so it's positive 6. How would I make a negative 6? Well, one thought might be, let's just make this negative here, this sign, and set all of these other bits just like they were. So is this negative 6? Well, I could test it. I know if I add positive 6 and negative 6, I ought to get 0. So I'm adding them. 0 plus 0, 0. 1 plus 1, 0, carry the 1. 1 plus 1 is 0, plus 1 is 1, carry the 1. Now I've got 0, 0, 0, 1 out there for my sign. Well, now looking at this, I've got an 8 here and a 4 here. That's a 12. Hey, we might be onto something. Until I realize, oh no, there's a negative. That's negative 12. So this obviously doesn't work, because if I add positive 6 and negative 6, I ought to get 0. So the answer is in what is called 2's complement. Let's start off again with our positive 6. So there's my sign. That's positive 6. Let's flip all of those bits. So if it was a 0 before, now it's a 1, and vice versa. And then let's add 1. 1 plus 1 is 0. Carry the 1. What do I get? 0. There's our sign. So this is what negative 6 should look like in 2's complement. Let's test it. Let's put our positive 6. Well, let's actually try and put positive 6 there. There's our positive 6. Let's put our version of negative 6 here. And let's add them. So I've got what? I've got 0. 1 plus 1 is 0. You carry your 1. 1 plus 1 is 0. Carry the 1. 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 And that means the sign is that, and a bit gets carried out. Well, y'all, that's 0. So 2's complement is the way to go when you're trying to get the negative of a number. Okay, all of that was just to get us to here. If you're converting sign numbers back and forth, you got to be really careful. So the first thing you do is you check to see the sign bit. If it's a 0, then you just go ahead and convert as though it were an unsigned number. On the other hand, if that sign bit is a 1, you're dealing with a negative number, and you have to do a couple of steps. Here is a signed number. I know it's a negative because this sign bit is 1. That means I've got to get the 2's complement of this number. So I'll do that. I'll flip the bits. And I'll add 1. Now what is this number? Here's my 64, 32, 16, 8, 1. I add all of those up, and I'm getting 73. All right, that's sort of the absolute value is the way to think of it. So to convert this number up here in 2's complement to decimal, my decimal answer would be negative 73. But what if we're talking about hexadecimal? Let's look at a 16-bit hex number. You all know that 16 bits is 2 bytes, and that each pair of digits here in hex is 1 byte. So I'm looking at 2 bytes here. That's 16 bits. Let's say our number was 3A B6. Well, how do I convert that? Now, is that negative or what? How do you tell? Convert each of these to the binary equivalent. So a 3 would be what in 4 bits here? 0, 0, 1, 1. A would be what? 1, 0, 1, 0. B would be what? 1, 0, 1, 1. 6 would be 0, 1, 1, 0. Take a look and make sure I did that right. So where's the sign bit? Well, it's right here. That's a 0, so I can just convert this to decimal just like I would, at any other time. How big does this last digit have to be for this to be a 1? And the answer is it's got to be at least 8. So let's look at another one here. Let's say this is 8 to E5. All right, and I convert to binary down here. I'm telling you, if this last digit is 8 or bigger, you've got a negative number if these things are signed. So this would be what? 1, 0, 0, 0. This would be 0, 0, 1, 0. E is the same as what? 14. So I've got this, and 5 is 0, 1, 0, 1. Take a look. Here's a sign bit. It's a 1. That means this is a negative number if it's a signed number. So now what do? Well, I do the same thing I did up here. I take the 2's complement. If you read in the book, it says subtract each hex digit from 15. So 15 take away 8 is 7. 15 take away 2 is 13, which is D. 15 take away 14 is 1. 15 take away 5 is 10, which is A. And then you add 1. Okay, so 1 plus 10 is 11. Now then, what is this thing? This place value out here in hex is 4096. I multiply that by 7. I'll do that in just a second. This place value is 256. I multiply it times 13. This place value is 16. Multiply it by 1. And this place value out here is 1, and I multiply it by B, which is 11. So I know that that's just 11. Let me do the multiply on all these others. Be right back. Okay, I'll multiply all my numbers. I get this, 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 and then my 11. I add them all up, and I get 32027. But remember, we were dealing with a negative number to start with. So the decimal equivalent to this negative number right here is negative 32,027. Watch out for those negatives.